we are going to elaborate. Let us read out the question once again. Explain the structure of glucose. First, I will explain you the structure, description of glucose, and finally some extra knowledge I want to give you about glucose and glucose structure. Particularly, we want to know in which category of biomolecule the glucose is going to be read in our textbook. Let us come on what is glucose. Glucose is a carbohydrate and it is called hydrate of carbon because it has general formula CxH2OY, where X as well as Y are equal to 6. Therefore, it is called as perfectly tally with the formula of carbohydrate. It is commonly called as aldohexose because it has aldehyde group having 6 carbon atom. So complete word is aldohexoses. It is commonly called as dextrose by the common people, and it is the most abundant sugar on the surface of earth, which is widely distributed all over the food material, fruits, vegetables, carbohydrate, which we take regularly like honey, like grapes, similarly like our carbohydrate like wheat, rice, etc. Molecular formula is C6H12O6. Let us elucidate the structure of glucose, which is very, very important from examination point of view. First of all, we'll prove the glucose has got 6 carbon atom by carrying out reaction with Hi. When glucose is heated with hydrogen iodide, we can think about its basic structure of glucose is simplified structure of glucose with OH group and CH group, because as we said earlier in second point, it is aldohexose. Therefore, the point is it is aldohexose. When we are talking about this is aldohexose, so let us look a basic structure of glucose which has one of the aldehyde group which is written at the top. The second position, the 4 carbon atom with OH group are written in the center, and the last is simplified structure in order to show the 1 carbon is left, which is written at the last, at the end carbon atom with OH group, which is mentioned here at the last terminal carbon atom. Let us react with hydrogen iodide. It gets reduced completely with Hi and on heating, and finally it on reduction, or you can say after removing this O, it is converted to the 6 carbon atom compound, which is called as N-hexane. N means normal hexane, a straight chain compound with the 6 carbon atom. You can see the students, you can see here there are 6 carbon atom in the chain. That means glucose must have 6 carbon atom. It is a proof of 6 carbon atom in glucose. Let us go on the next set of reaction where we want to prove that glucose has got carbonyl group. As we said, glucose is aldohexose. That means even it is a polyhydroxyaldehyde. Since it is polyhydroxyaldehyde, it must have 1 carbonyl group. So which type of carbonyl group is there that we will prove in the next set of reaction. But here is one of the carbonyl group is we are showing the reaction of carbonyl group with the next reaction which we are dealing now, students, that is reaction of carbonyl group. Here is your carbonyl group. Carbonyl group are 2 types, students. One is called aldehyde and another type is called ketone. Same glucose is aldohexose. It is polyhydroxyaldehyde. So here is your aldehyde group. We are proving this is a kind of carbonyl group. We have 2 reactions here. One with hydroxylamine. As you know, hydroxylamine is a substituted compound of ammonia with OH group, replace H of NH3 by OH. It is called NH2, it is written as NH2OH. When the reaction is carried out between a carbonyl and hydroxylamine, the O from aldehyde removes a molecule of water from H2 of hydroxylamine, which is attached with N, and finally there comes a double bond between CH double bond NOH by removing O and H2 from this reagent. This compound is called oxime. The glucose oxime and glucooxime formed after the reaction. Other part remain the same as it is, CHOH whole 4, CH2OH as it is. So oxime is formed as a result of reaction, which is a colorful compound. It shows the glucose has got one of the carbonyl group. Another way we can also show that it is a carbonyl group is another set of reaction. We are dealing with the reaction with hydrogen cyanide, HCN. Student, you must know the carbonyl group has got polarity. There is a polarity in the group due to the presence of this electronegative oxygen atom. It pulls the electron toward itself. Therefore, oxygen acquire negative charge, carbon acquire positive charge. Similarly, HCN is also a polar compound which is reacted here. The hydrogen will be partial positive charge, and cyanide group CnC will acquire a partial negative charge. Whenever a reaction takes place with HCN, opposite radical will be going to attack here, the H to O and Cn to CH. So finally your compound will be CH, Cn and OH attached. This is called cyanohydrin. Remaining part will remain the same, student, CHOH whole 4 and CH2OH. This compound is called glucose cyanohydrin. So you can see that two reactions are proving the same matter, same concept. The glucose has got carbonyl group. Let us come on what kind of carbonyl group is found in glucose. Is it an aldehyde or ketone? अभी तक आपने पढ़ा कि ये ग्रुप आपका कार्बोनाइल है, और कार्बोनाइल आपके दो तरह के होते हैं, एक one is aldehyde, other is ketone. So we want to justify that this group is an aldehyde group. We have to go reaction of some weak oxidizing agent, not a powerful one. Otherwise, it will start affecting the other group which are also found in the organic compound. The weak one can be a bromine water, which can convert CH group to the COOH group. It is a weak reagent which can convert CHO to carboxylic acid. So here comes this reaction which is being discussed, which is in front of you. The CHO, CHOH whole 4, CH2OH is your glucose reacting with bromine water, oxidizing the aldehyde group only and converting, as you know, the aldehyde group on oxidation gives carboxylic acid. 1O is supplied in this reaction by the reagent, and finally it converts to COOH. Rest functional group remain as it is. This particular product is called gluconic acid. So let's prove the remaining functional group which are there. So far we have dealt with the glucose has got 6 carbon atom, glucose has got carbonyl group, and glucose has got aldehyde group as one of the carbonyl group. It is polyhydroxyaldehyde. How do we prove that? How many OH group are found? In case of glucose, a very wonderful, interesting question in glucose. For visualizing this part, we undergo reaction of acetylation with acetic anhydride. Acetic anhydride is your CS3CO COCH3 reagent. When it undergo this reaction, it will remove a molecule of water from the OH group. 5 molecules of acetic anhydride are reacted, and finally the CS3COOH is being removed, acetic acid is removed, and other component of acetic anhydride is going to form the ester group with the primary as well as secondary functional group. There are 2 types of OH group you can see. One is at the terminal, another is in center of the carbon atom of the glucose. As a result, it forms penta-acetate derivative. So glucose penta-acetate is produced in this reaction. It shows the glucose has got 5 OH group. Let us come on the next slide. So students, further we want to know which 2 types of OH groups are available in case of organic compound, that is a glucose. 1, primary, second should be secondary. To understand this primary and secondary functional group, that is OH, primary is attached with the terminal carbon atom and secondary will be attached with the center carbon atom. For that purpose, we undergo the strong oxidation reaction with strong oxidizing agent, that is a concentrated nitric acid. Here we undergo reaction with strong reagent, concentrated nitric acid, which is written as oxidation over here. Both the functional group CHO as well as CH2OH at the terminal position are going to oxidize since it is strong. जो भी strong होता है उसमें ज़्यादा ability होती है और आपके first और last दोनों ही oxidize हो जाएंगे और finally it will convert into saccharic acid. This is called dicarboxylic acid 1 and 2, and this compound common name is with the 2 COH group oxidation is called saccharic acid. This also produced by gluconic acid also, because gluconic acid, as you noticed in the previous slide, has got COH group as a at the first carbon atom. Once it are oxidized, it also gives you same product, but difference is you are getting the next member by 1 COH group, but this also proves in another way the glucose has got the 1 aldehyde group as well as 1 primary OH group. Here we come to the Fischer projection formula. The extra information I'm giving you about the glucose structure, that is Fischer has proved that glucose structure can be elaborated into a standing posture structure. जैसे हम खड़े होते हैं वैसे ही हम ग्लूकोज का स्टैंडिंग पोस्चर बनाते हैं, where we write the most oxidized carbon atom at the top, that is CHO group, the least oxidized carbon atom or the less oxidized carbon atom at the bottom, and the remaining carbon atom are shown by the help of the vertical line, which are shown per parallel by the cross structures. You can see the first carbon atom is at the top, second carbon atom is after that, where H and OH are shown towards the left and the right side. Third carbon atom is inverted. The inverted position of H and OH will be proved, which we will study in the higher classes, because up to 12th standard, you have to understand the Fischer projection formula. H and OH atoms are aligned left as well right direction, but the inversion at the third position, that will be a part of the textbook that you will prove in the later classes. The fourth carbon atom, you will have left side H and the OH, rest all carbon will be same. As I told you, the minimum oxidized carbon atom will be at the last. Second and third structure are of saccharic acid as well as as well as a gluconic acid. Similarly, these can also be shown by the Fisher projection formula, but we are concentrating towards glucose structure, how it is. As you know, it is called D plus glucose. D capital plus glucose. In the next slide, we will discuss about why this particular structure is called D plus glucose. We will discuss this structure in this present slide. We commonly say, students, that glucose is named as D plus glucose. As mentioned on the right hand side, you can see this is D plus glucose. Why glucose is termed as D plus glucose? Let us look upon this factor. It is a configurational relationship. It is a relative configurational relationship with the compound named D-glyceraldehyde, which is written on the left hand side. It is a simple 3-carbon atom compound in which H and OH relative position of the second carbon atom, or you can say second last carbon atom, will be towards the right hand side. Right hand side is OH group and the left hand side is H atom. If the second last carbon atom of glucose has representation OH towards the right side and H toward left hand side as similarity with D-glyceraldehyde, then it is named as D plus glucose. But what do you mean the plus sign here? Because in between naturally it will come in your mind to understand. आप जानना चाहेंगे कि ये प्लस साइन क्यों आ गया इस स्ट्रक्चर में. प्लस साइन को समझने के लिए हम ऑप्टिकल एक्टिविटी का सहारा लेते हैं. If a particular compound rotate the plane polarized light towards the right hand side, we says it is dextrorotatory, that means D form. आप उसको कहते हैं dextro या D form या plus form. So glucose, which is commonly known glucose, which is commonly used in the nature, that is dextrorotatory, that means a plus form. So here it is a dextrorotatory compound. इसका रोटेशन पॉजिटिव है, आपका राइट साइड रोटेशन है, इसलिए हम इसका नाम देते हैं D plus glucose.